Welcome to EDU World Space.
For a system of three particles, A, B, and C, three masses are 3, 2, and 4 kg respectively for A, B, and C, and their velocities for A, B, and C are 4i plus 2j plus 2k, 4i plus 3j, and minus 2i plus 4j plus 2k respectively. So since we have the masses and the velocities of each particle, we can actually calculate the linear momentum for each particle. The linear momentum will help us find the angular momentum later on. So the linear momentum is simply the mass of the particle times its velocity. So for particle A, that's MAVA. And if we do the scalar product, we get the linear momentum for particle A to be 12i plus 6j plus 6k. Doing the same for particle B, MBVB is equal to 8i plus 6j. And finally, the linear momentum for particle C, MCVC, is equal to minus 8i plus 16j plus 8k. So now we have linear momentum. We need one more variable in order to find our angular momentum, and that is our position vectors. So the position vectors relative to the origin O can be read off simply. So for A, particle A is at a position 3j from the origin. Particle B, in basis vector notation, is 1.2 along the I direction plus 2.4 along the j direction plus 3 units in the k direction. And the position vector for C is simply 3.6 along basis vector I. So now we have the linear momentum and we have our position vectors. So we can calculate our angular momentum about the origin, so about point O. And our angular momentum here is in SI units, kg meter squared per second. So angular momentum is denoted by h, and it's around the origin, so we put subscript O. And this is defined as the position vector RA crossed with the linear momentum. So for particle A, that's MAVA plus RB crossed MBVB. So the angular momentum of the entire system is the sum of the cross product between the position vectors for each particle and the linear momentum. So it's RC cross MC VC. And hence we have an expression for angular momentum. And we'll use the method of cofactors to find h, to find the angular momentum. So using the method of cofactors and knowing how to calculate the determinants, we can simply calculate the value for h. So for particle A, we have r cross p essentially, which is the linear momentum. R is 0, 3, 0, and mv is 12, 6, 6. We're suppressing the units here. For particle B, it's 1.2, 2.4, and 3 for the position vector r, crossed with 8, 6, 0. Particle C, It's 3.600 crossed with -8, 16, and 8. And if we perform this cross product, we get 18i minus 36k plus, for particle B, minus 18i plus 24j minus 12k. Finally, for the last cross product, plus minus 28.a times basis vector j plus 57.6k. And if we perform this, so we can add all the like terms, we get 0i minus 4.8j plus 9.6k. So hence we've calculated our angular momentum. So our angular momentum h naught is equal to minus 4.8, and the units are kg meter squared per second in the j direction plus 9.6 kg meter squared per second, and that's multiplied by the basis vector k. So that's our angular momentum of the system of three particles about the origin, point O.